So we are pleased to introduce the first speaker for this afternoon, who is Robert Barouki, who is Professor of Biochemistry and will speak about exposome. So you have the
Thank you.
mic.
Okay, thank you very much for the invitation to speak about environment. I am a toxicologist, I have to say, and happy to speak before maybe an audience made primarily of epidemiologists, but I think we are, as I will try to show you in this talk, I think we are in a period and a time where we have to have a multidisciplinary approach to almost everything, so I'll try to make it. I will speak about, I will speak about mostly the exposome, but let me start by a few definitions about the environment. I think it's important, especially in a public health perspective, to have a good definition, because that's a source of a lot of misunderstandings. The environment can be either taken in a very broad definition, anything that is not genetic, which includes behavior, which includes stresses, all kinds of stresses. It can also be taken in a more targeted way and a specific definition, which is basically passive exposures. For example, if I smoke, this is behavior, but if somebody next to me is smoking, this is environmental effect. So it's mostly then pollution, contamination. It's extremely important to distinguish between those two, because I think many of the misunderstandings are related to different definitions. Health has also different definitions, and it's interesting to see that when it used to be perceived as basically the absence of disease initially, now it's getting a much broader definition, like well-being, and with the incoming, one word, one health, eco-health, one health, whatever concepts, it's becoming much closer to the environment, in fact. So environment and health makes quite sense to bring them both together. If you do the literature, there are a very large number of diseases where, at one point or another, somebody said that environment is involved. And they can be, of course, on one hand, infectious, but also chronic diseases like these ones. Of course, I am not saying here that pollution is responsible for all these diseases. Of course not. Many of those diseases have many other causes, including genetic causes or nutritional or behavioral or whatever. But I'm saying that at one point or another, somebody said that maybe environment is contributing and maybe some pollution or contaminants are contributing. So there is also an increase in non-communicable diseases, and this has been studied and shown in a number of different cases. This is the case of obesity, and you can see how bad it is. At the same time, this has happened during the last decade. At the same time, environmental stressor and pollution has increased. Of course, this is pure correlation and doesn't mean by any means that it is causality, but at least it leads us to generate some hypothesis and try to understand whether those increases in pollutant exposure could be involved in some of these diseases, and how much, what percent, how much they interact with other stressors, and that's, I think, a very important issue. And you can see this this figure from the Lancet last year, showing that in general, total pollution is a major factor that could be responsible for death. It's actually probably more important than other factors, but at least we have to study this. We have to take this into account and see how we can do it. And basically, the rest of my talk will be focused on a concept called the exposome, and try to show you what is this concept and how we can make it in practice, how people are studying it. And I will really show you a number of examples coming from European projects that are ongoing or have been ongoing for the last few years in the field of exposome research, to show you in practice what it is. Exposome was actually born in 2005 and the name was coined by Chris Wilde, the IARC director at that time. And basically, the reason why he thought that a new concept was required was that, well, a lot was known about the genetics and cancer, and whether it's the genetics of the cancer cell or the genetics in general. So on the other hand, when you have non-genetic factors or stressors, then things were much less clear. I mean, it was like infection, pollution, behavior, whatever. And so it was a sort of a mess, and he thought that it was good to have one concept that brings all those other stressors together. And he coined the term exposome as the totality of exposures an individual is subject to from conception to death. So there are two aspects, the totality of exposures, and in that sense he means exposure to chemicals, to physical stressors, to biological stressors, but also to psychological stressors and social stressors. So all mixed up at the same time, but also there's a time aspect, and this is extremely important. You take into account the full time. So that's his own definition. Some people call it the wild concept because it's so large that, I mean, the question is how can we make something out of it in both in research and in relevance to public health. Well, as happens usually when people have a new concept, other people come and add something to the concept, make it a little bit more focused or less focused. So after the wild concept, you have people like Stephen Rappaport and Michael Smith who have focused mostly on what they call the internal exposome. Basically, take some blood samples or urine and do some assays on it and have a good idea about what are the stressors that are involved and how the organism can react to those stressors. So they are basically focused on chemical exposome, but they think that when the chemistry of the blood also reacts to any type of exposure. So it made sense for them to focus on so-called internal exposome. And this is mostly actually what I will be showing a little bit later. But an epidemiologist like Germaine Buck-Lewis had a more larger view of the thing and insisted more on so-called community effects, macro-level effects. So it's a wider view of the exposome. And the National Research Council in the US made a report a few years ago linking exposure of human beings to what's happening in ecosystems. And they called it the eco-exposome and showed how the interaction could be between what's happening in the ecosystem, in the environment, and their effect on human, and vice versa, the effect also of human on the environment. So this is shown here. If you take a source of, for example, pollution, it ends up as a stressor to a receptor being a human being, for example, then there's a response, and that response could influence the source as well as individual behavior. So they showed these interactions. It's a nice way, you know, one word, basically, one health and the same environment. It's important to insist that the exposome, in its really general definition, is the complement of the genome, but there are other omes that are important, as you know, the epigenome, which is actually influenced by both, as well as the microbiome. And in addition to this maybe public health view or community view of the exposome, I think if you combine all these, you can end up having a more individual view. What is the individual exposome? Is that of any relevance in medicine, and could we use it in the future like we could use, for example, the individual genome? And that's a real question that we can address a little bit later. It is complex. The least we could say, it is a complex, concept, and we have to acknowledge that. It's not something that we can start like working on very quickly. There are many issues when you're working on an exposome project. What type of stressor you're interested in, and basically what type of interaction between stressors you're also interested in, physical, chemical, biological, psychosocial. What is the source? Is it air? Is it water? Is it food? Is it behavior? Where are you exposed to those things? Is it at home, at school, at work? What type of effect? Organs, tissues, and I will speak about adverse pathway a little bit later. And specifically when. This is the time courses, the time at which the exposure takes place is extremely relevant and important. And we know that there are some more vulnerable periods of time, like, for example, the fetal period. And that's something we have also to address. Most of the projects in the exposome field are extremely wide. They address a number of different things, and it's important to do that in a way, because that's how you could maybe interact with different specialties and try to bring something together. So you have to think globally, but basically we have to act locally. I'm a toxicologist, so I will be working mostly on these mechanistic aspects here, but of course, you need to characterize the exposure and the kinetics in an individual up to the community level. So it's mostly about collaboration between different groups and trying to address a question. One of the important aspects of the exposome is the interaction between stressors, and I think that's one occasion. Because you are characterizing different stressors, you can address the interaction between these different stressors. I'm really taking one example, and without any much detail, coming from Denise Miroux's lab, a paper lately. It's about the air pollution in Paris, and you can see that it is quite high where there's a lot of traffic at the ring, the périphérique of Paris, but it's also high at the Champs-Élysées. Maybe less these days on Saturdays, but it is reasonably high. So, and the people who live in one close to the périphérique and those who live close to the Champs-Élysées are not exactly the same in terms of social status or socio-economic status. And he showed in that paper that there is different in the effect, in the risk on the people depending on their socio-economic status. I'm not going into detail. There are many biases that could explain this, but just to show you that it's good to have different stressors and try to combine them. The exposome concept actually it's I would say in its puberty. It was born in 2005, and now we are 14 years later. When Chris Wilde published his paper, I don't think many people read that paper. It was not a very famous journal anyhow. I mean, a good journal, but not very famous. For a few years, he said that nobody reacted to it. I mean, nobody really cared. And suddenly, the US and in Europe, people suddenly started to care about, and there have been a number of different projects going on through FP7 and H2020 in Europe and in the US. I'm going to go through these projects and basically use these projects to illustrate one important aspect of exposome work. What do people do to explore the exposome? Is that enough? Should they? And what did that lead to? Here are the three major exposome studies in Europe: Exposomics, Helix, and HEALS. I'm including also the human biomonitoring project, which has some aspect of the internal exposome in it, of course, mixture programs, and giving you one example from the US, the Hercules program. Concerning HEALS, which is one of the exposome, HEALS is mostly about modeling, in fact. There are many different people working, but there's a lot of epidemiology, some toxicology, and a lot of people working on modeling. And one important aspect to determine what are we exposed to in our environment is the use of either remote sensing or environmental and personal sensors that could tell you a lot, as I will show you later. Then to do a lot of exposure modeling, and going from that, then do the more usual epidemiology with a lot of omics and kinetic studies, and in addition to mechanism of causality. I will illustrate that a little bit later in one example, but I would like to stress the importance and the development of these tools that we have that are sensors that could detect either physiological parameters or exposure parameters. You can detect noise, you can detect UV, you can detect particles, you can detect the number of organics. So you can put them in a room and have a good idea about what kind of exposure we have here. This is sort of old style now, it's becoming much more modern and smaller, but I think this is something that will be developing at a very fast pace in the future. And then the people in HEALS do a lot of modeling, something called agent-based modeling, following a person during, for example, a day or during years, and modeling their exposure. I mean, where do they live? Do they take the metro? Do they go to a chemical factory where they work and then take the metro back, and how they are exposed? They are trying to do this kind of modeling. The Helix project is about actually the pregnancy exposome. It focuses on childbirth, on birth cohorts, and they have brought together several of those cohorts. Many of you know about them. And they have tried to combine this cohort to study a number of things, among them a number of pollutants that they have assayed, as well as other factors and stressors, and basically started doing some correlation between each pollutant. If I show you this plot here, you can see these are pollutants here, and you can see basically that when you are contaminated by one pollutant, you are likely to be also contaminated by the others from the same family. If it's a persistent organic pollutant, you are likely to also be contaminated by other persistent pollutant, or if it's phthalate, by other phthalates. But sometimes you have some other correlations that are interesting and relevant to be studied. So the major focus of Helix is this period of time, the pregnancy exposome. Exposomics has a focus mostly on air and water, so it's the source, but also a lot on epigenetics. And for example, they have taken one, the ALSPAC epidemiological studies, and studied exposure to particulate matter, air particles, which they were able easily to determine, and then followed the children at different ages and did a lot of epigenetic studies, and basically attempted to see which epigenetic marks are more or less correlated with exposure during pregnancy to these particles. So this is this kind of birth study where they are doing a lot of epigenetics to try to see whether epigenetic is a good target for all these exposure. Again, I will mention this a little bit later in my talk. Concerning the biomonitoring study called HBM4U, this is a huge program. This is a 74 million euro program across Europe trying to do biomonitoring. And human biomonitoring is all about determining what kind of compounds and substances you have internally, for example, in blood or urine or hair or nails, whatever. But this is the general view. This is the traditional biomonitoring, having representative populations and doing that kind of work. Let me show you another view of maybe a personal view, a toxicologist view of biomonitoring, where you have the internal dose here. But the internal dose is obviously the result of different sources of contamination. And it's basically the study of how these different sources end up in an internal dose can be summarized as aggregated exposure pathways here. Then you have the kinetics of this internal dose within the body. You can determine, for example, if you have the amount of substance in blood, you can project and do modeling and to determine how much of it will be in the brain or how much will be in the adipose tissue or in the liver. And from there, you can try to correlate this to possible adverse outcome pathway, which are mechanistic frameworks that describe a pathway explaining an adverse outcome, for example, cancer or heart disease, whatever, starting from a molecular initiating event through different key events and ending up with an effect. So one of the approaches that we are following in this program is to try to link a chemical. Here it's bisphenol S. You may have heard about bisphenol A, and bisphenol S is a similar compound that is actually a substituent to bisphenol S, to bisphenol A. And the question is it safe? So based on a new tool, based on text mining strategy and artificial intelligence tools, we were able to connect bisphenol S to a number of different events that occur in different adverse outcome pathway, and basically to show through these are the pathway, these are the molecular initiating event, these are the key events, and then you have the obesity as a pathway, to link bisphenol S to increased adipose tissue amount and obesity at the end. In the US, the approach was slightly different, and there are a number of programs that address exposome work, but one of them is Hercules, which is all about building a facility of analytical assay for different substances in blood and urine, and putting this facility at the disposal of all people who have epidemiological or toxicological study that would like to have this kind of exploration. So they're good in these analytical studies, and from a single biological sample, they can do both what they call the chemical exposome, which is mostly exogenous substances, contaminants and pollutants, and at the same time, the metabolome, which is the endogenous metabolome, which is sort of one way to assay the effect of these substances. I mean, doing it at the same time. This is using different analytical tools, and my friend Gary Miller likes to represent this. I know many people working in genetics here, and he says, well, in genetics, with a single assay, you have so many millions of SNPs that you could detect, whereas until now, in the chemical exposome field, we are still dealing with a few hundreds, if you're really good, a few hundred compounds. But basically, the analytics could go a little bit further and much better, and go up to a much larger amount. I think I would skip this example showing different, but I would like to insist here on one important aspect, which is long-term effect and basically epigenetics. And I think from a mechanistic point of view, this is something that is extremely difficult, addressing long-term effect. Why a disease only appears either after an exposure that lasts for tens of years, or after several years or tens of years after the exposure. How could that be? And from our point of view, it's extremely difficult, because it's extremely difficult to have models, animal models, for example, or other models to deal with that. But yet, things have progressed now, and you can have different modes that could explain these long-term effects, either reiteration of the exposure or the internal persistence of the exposure. But mostly, I think, the most exciting mechanism that is happening in the field is so-called programming. I mentioned a number of time birth cohorts, and exposure during this fetal period, which is a highly vulnerable period, could translate not directly, not immediately in an effect on the fetus, but could translate much later with an effect that appears much later. So I am told that I have been speaking too much, so I would like to end up with a couple of slides, 2 minutes, just showing the implication of the exposome work, maybe more practical implication. I think exposome studies will lead, and have led already, to a considerable increase in innovation, particularly in those tools, for example, in sensors, in monitoring, in modeling, etc. And I think this will promote this innovation and the development of the tool. It also is a way to have a multifactorial concept of disease. So you were wrong. Okay. She was tired, and so it's not very, Okay, I think you all know. What I wanted to show before is the relevance of epigenetics in our field, because of the importance of to explain how exposures at one time could lead to an effect that would appear much later in time. I think it may not be only epigenetic, but it is important to explore epigenetics, because this is one reasonable mechanism that should be explored. And epigenetics could be, you can view it as, there are two sides to epigenetic marks. It can be either a mechanism of the disease, I mean, the stressor leading to a difference in methylation of DNA or histone, whatever, and it could be the start of a mechanism of disease. And there's some evidence for that, either in toxicology and sometimes in epidemiological work. But it also could be simply a marker of the exposure. And that's extremely important, because, as I said, very often the exposure could happen at one point and the outcome much later. So you don't have the exposure when you are studying the people who are sick. You don't have the exposure anymore. But if it is true that the exposure leads to a difference in epigenetic marks, then those marks, maybe they could remain. Of course, epigenetic marks are reversible, but some of them are actually can remain for years and years, and this has been shown. So they could represent at least markers of exposures if they are not also part of the mechanism of the disease. So it's really important to focus on these epigenetic marks. And my hope is that in the future, the same way as we have today tests on genotoxicity, mutational activity of an exposure, at one point we could have reasonable and reliable tests and robust tests on epigenotoxicity, where you could see whether a compound leads to an epigenetic modification, and following that, try to draw some consequences for the toxicity of the compound in the long future. This is something that I think is quite important. So, as I said, implications is some innovation and also a multidisciplinarity both in research as well as in education and training, and I think this is quite important. But also we may have some implication in public health in terms of regulation. I mean, for example, most of the regulation today is done on each substance one by one. You know, you regulate this pesticide, and you regulate this plastifier, and you regulate this compound. And we know that the exposure is a mixture of a number of compounds. So there is not yet a real tool in regulation to address that. There is not really yet also a reasonable tool to address the combination, for example, of diet and exposure. So all these should eventually come, and concerning the mixture of substances, many agencies are currently working on them to see how they can introduce in the regulation and translate the fact that we are not exposed to a single contaminant, but we are exposed to a large number, maybe hundreds of thousands of compounds, and how could we introduce that and use that? There are also a lot of focus on vulnerable populations, as I have shown, and that's quite relevant in public health, as well as the public health message. Let me give you an example. If you take a public health message in nutrition, we are told to eat vegetables and fruit every day, which is fine. But on the other hand, you know, a toxicologist like me would go to the radio and say, well, pesticides are something that you may not want to be contaminated with. And, you know, like, so people have to understand, I mean, what should they do? Same with fish and metals, heavy metals and POPs, etc. So I think public health messages could be inspired by this combinatorial exposome thinking. And finally, the question is, the same way as I think we have talked earlier about precision medicine, could we use all these tools, all these information to have a more, to use them in prevention and have a more precise prevention? For example, knowing exactly what is the exposure, that we are undergoing. For example, somebody with asthma may benefit from some of these sensors that could tell what kind of compounds are around and whether they may suffer from that. So I think this should be something that is important. And with that, I would like to thank you very much and for listening. And sorry for having too long.